Welcome to Exec Class Hub. My name is Dr. Brain, and I am your chemistry teacher for today. So today we are going to be starting a new topic, and the topic we are going to be looking at today is chemical kinetics. Chemical kinetics. So today we are going to be studying chemical kinetics, and chemical kinetics is a branch of chemistry that deals with the study of the rate of a chemical reaction, the factors that affect the rate of a reaction, and the mechanisms, that is, the series of steps by which a reaction occurs. So let me repeat that again. So talking about chemical kinetics is a branch of chemistry that deals with the study of the rate of a chemical reaction, the factors that affect the rate of a reaction, and the mechanisms, that is, the series of steps by which a reaction occurs. So from that definition, you notice that we listed about three things. Number one, we said rate of a chemical reaction, rate of a chemical reaction, rate of a chemical reaction. Now, it is very, very, very pertinent that I emphasize the fact that whenever anything is called rate in science, a particular factor must be involved, meaning that you cannot talk about rate without the involvement of this factor. And this factor that we are talking about is what we call time. Time. So what am I saying in essence? What I'm saying in essence is that anything that is called a rate must involve time. In fact, the reason why rate is called rate is because time is involved. So, in the context of chemistry now, since we are talking about rate of a chemical reaction, now, first of all, in chemistry, we normally represent a chemical reaction in the form of a chemical equation. So, take for instance, A plus B to give C plus D. This is a chemical equation, but in chemistry, chemical equations represent chemical reactions. So now, A plus B to give C plus D. In this chemical equation, which is representing a chemical reaction, A plus B represents the reactant, C plus D represents the product. So now, what do we then call rate of a chemical reaction? Rate of a reaction. Rate of a reaction is the change in the concentration of either the reactant or the product with time. Now recall that I mentioned the other time that for we to say something is a rate, or for we to call something a rate, time must be involved. So when we are talking about the rate of a chemical reaction, it is the change in either the concentration of the reactant or product with time. So when the concentration of either the reactant or product is changing with time, then we describe that as rate of a chemical reaction. So therefore, we can say rate is the change in the concentration. Now, this symbol in chemistry represents concentration of either the reactant or product. Let's say A, for instance, of reactant A, all over change in time. So this is what we call rate of a chemical reaction, when the concentration of reactant or product is changing with time. All right, that's stated. Let's move on. So now, having established that, so how then do we write rate expression for chemical reaction? So take for instance, if you have a reaction of this nature, AA plus BB to give CC plus DD, for example. Now, in this reaction, your small letter A is the coefficient or the number of moles of reactant A. Small letter B is the coefficient or the number of moles of reactant B. Small letter C is the number of moles or coefficient of product C, while our small letter D is the number of moles or coefficient of the product D. So if you want to write the rate expression, for instance, if you are being told to write the rate expression for this particular reaction, our rate expression, that is the expression for the rate of the reaction, becomes minus 1 over A, change in the concentration of A, all over change in time, which is also equal to minus 1 over B, change in the concentration of B, all over change in time, all right, which is also equal to 1 over C, change in the concentration of C, all over change in time, is also equal to 1 over D, change in the concentration of D, all over change in time. So this is how to write rate expressions for chemical reactions. So when you are being told to write the rate expression for any reaction, this is how to write the expression. But meanwhile, you notice that in this rate expression, you notice that the reactants carried a negative sign, while the products do not carry a negative sign. So why is it like that? I will explain. Now, it is very pertinent that we understand that. Now, recall that we said that when we are talking about rates, it is the change in the concentration of reactant or product with time. So now there are two things you need to understand. First of all, the concentration of reactants decreases with time. The concentration of reactants decreases with time, while the concentration of product increases with time. The concentration, okay, let me put that here. The concentration of reactant decreases with time, while the concentration of products increases with time. So now, if we are to look at these statements together, so we said that the concentration of reactants decreases with time, while the concentration of products increases with time. Then the second thing you need to pay attention to is that rates of a reaction can never be negative. Rate of reaction can never be negative. So these two statements will explain the reason why reactants normally carry a negative sign in the rate expression and products do not carry a negative sign. So let me begin to explain that one after the other. So for instance, since we said that the rate of reaction of reactants decreases with time. So now, remember that rate is change in concentration all over change in time. So let's use reactant A, for example. Recall that anything that is called change is always final minus initial. Final minus initial. So when we say something is change, that is final minus initial. So for instance, since we are considering reactant A here, for instance, now recall that we said that the concentration of reactants normally decreases with time. So let's say that, for instance, if the initial concentration of reactant A is 100 molar, for example, since concentration of reactants decreases with time, that means the final concentration of A must be something that is lesser than 100 because it decreases with time. So, for instance, let's put it at 80 molar. So let's assume that this concentration change from 100 to 80 at a time t is equal to 5 seconds. at a time t is equal to 5 seconds. So let's attempt to calculate the rate for reactant A. So the rate now becomes, now, change in concentration of A, that is final minus initial. That becomes 80 minus 100 all over the time, which is 5 seconds. 80 minus 100 is 20 divided by 5. 80 minus 100 is minus 20, divided by 5. That will give us what? Minus 4. Now, but remember, I told you that the rate of a chemical reaction can never be negative. So that is the reason why a negative sign is always included for reactants. The reason being that we already know that since the concentration of reactant decreases with time, when we calculate the rate using our final minus initial, it is going to give us a negative answer, which is not allowed. So that negative is always included for reactant. So that negative can cancel negative. So at the end of the day, we are going to have a positive what? Answer. But for products, it is not like that. For products, it is not like that. So why do we not need to include a negative sign for products? Why do we not need that? So, for instance, the rate, let's consider a reactant D, for example. Let's calculate the rates for, product D. So that is change in concentration over change in time. Change in concentration of D all over change in time. So we want to attempt to calculate the rate for product D, for example. Now, since D is a product, now remember we said that the rate of reaction of product increases with time. So since D is a product, that means that, for instance, if the initial concentration of D is 50 molar, for instance, the final concentration of D must be something that is greater than 50. Why? Because the concentration of product increases with time. So that means we can assume something like 100 molar, for instance. 100 molar, for example. So if that is the case, all right, let's say that this concentration is changing at a time t is equal to 5 seconds. So let's attempt to calculate the rate. So the rate of D now becomes, now like I told you earlier, anything that is called change is final minus initial. The final concentration here is 100. The initial is 50 all over 5. 100 minus 50 is 50 divided by 5. That will give us 10, which is positive. So we don't need to include negative for products. Why? Because product will always give us a positive answer. And remember, rate of a chemical reaction can never be negative. It has to be what? Positive. So for product, we know already that since the concentration of product increases with time, then definitely we are going to have a positive answer. So I believe that is clear enough. So that is why in the rate expression, you don't include negative for products, but you include negative for reactant. You include negative for reactant. So having said all that, so for instance, if you are giving a reaction like this, 2H2 plus O2 to give 2H2O. And you are being told to write the rate expression for this reaction. How do we write the rate expression for this reaction? The rate expression becomes R is equal to, now this is the reactant, that becomes minus 1 over 2, change in the concentration of H2 all over change in time, all right, is equal to, now, we don't need to write 1 over 1 because it will give us 1. So let's just put minus change in the concentration of O2 all over change in time, which is equal to, now, this is a product, so it will not carry a negative sign, like we said earlier. So that gives us what? 1 over 2, change in the concentration of H2O all over change in time. All over change in time. So this is how to write the rate expression for reactions. Okay, let's take one more example on that. Let's take one more example. So, for instance, if you are giving another reaction like this, let's assume you are giving a reaction of this nature, uh, calcium carbonate plus HCl, giving you calcium chloride plus H2O plus CO2. So let's assume we are given this reaction, for instance, and we are told to write the rate expression for this particular reaction. How do we go about that? The rate expression becomes R is equal to, now there is no coefficient here. And of course, you know that this is a reactant, so it has to carry a negative sign. So R is equal to minus change in the concentration of calcium carbonate all over change in time is equal to minus 1 over 2, all right, because the coefficient here is 2. Change in the concentration of HCl all over change in time, which is also equal to, now, all these are products, so it is not expected that we add a negative sign to them. So that becomes change in the concentration of calcium chloride all over change in time, all right, is equal to change in the concentration of H2O all over change in time, all right, is also equal to change in the concentration of CO2 all over change in time. So this is how to write the rate expression for chemical reactions. So, but the important thing to note here is that reactant will always carry a negative sign, while product will not carry a negative sign. All right, let's go ahead. Now, having said all that, it is also important that we also say that the rate of reaction, of reactants, decreases. The rate of reaction of reactant decreases with time. The rate of reaction of reactant decreases with time, while the rates of reaction of products, increases with time. Now, this statement is actually very, very important under chemical kinetics. The rate of reaction of reactants decreases with time, while the rate of reaction of products increases with time. Now, why is it like that? It is like that because during a chemical reaction, reactants are continually used up for the formation of products. So that brings about the fact that the rate of reaction of reactant begins to decrease, while that of the product begins to what? Increase. But this particular statement in exams, for example, is usually represented in the form of a curve. So you can have a curve like this, all right, with rates on this axis, then with time on this particular axis. So for reactants, we said that the rate of reaction of reactant normally decreases with time. So that will give us this kind of curve, decreasing with time. The rate of reaction of reactants is decreasing with time. But for products, the rate of reaction of products increases with time. So we are going to have this kind of curve indicating that it is increasing with time. So we can call this place the curve of reactants. We can call this place the curve of reactants, while we can call this place the curve of products. Curve of reactants, curve of products, curve of reactants, and curve of products. So this curve you are seeing here is emphasizing the fact that the rate of reaction of reactant actually decreases with time. Then this particular curve is emphasizing the fact that the rate of reaction of products increases with time. And under exam conditions, at times, on this axis, rates can be replaced with concentration. It can be replaced with concentration. At times, it can be replaced with pressure. At times, it could also be replaced with volume. So any of these three can replace rate on this axis, but nevertheless, the rule is still the same. Reactants will decrease with time, giving you this kind of curve, while product will increase with time, giving us this kind of curve. All right, so having established that, all right, and of course, this statement is true for all chemical reactions and even in normal life processes. At the beginning of anything, the rate is going to be fast, but with time, the rate will begin to decrease. So having said that, let's move ahead to all right. So let's talk about the rate law. The rate law. The rate law. So the rate law for a chemical reaction is always expressed as R is equal to K, concentration of A raised per M, and concentration of B raised per N. So this is what we call the rate law expression for a chemical reaction. And in this rate law expression, let's look at what all the species you are seeing. Let's see what they represent. So in this rate law expression, the R represents the rate of the reaction. The R represents the rate of the reaction. That is R. The rate of the reaction. Our K represents what we call rate constants. Rate constant, that is K. K represents rate constants. Then our A in brackets represents concentration of A. Concentration of A. Like I mentioned the other time, this symbol in chemistry represents concentration. Then our B in brackets represents concentration. Concentration of B. That's our B in brackets. Concentration of B. Then our M is order of the reaction. Order of the reaction with respect to A. Our M is order of the reaction. Anything here, not necessarily M at times. At times it could be X, it could be Y, anything at all. Whatsoever you find here is the order of the reaction with respect to A. Then our N is order of the reaction. Order of the reaction with respect to B. So N is the order of the reaction with respect to B. So all this is what they represent in the rate law expression. So like we said, the rate law expression is represented by R is equal to K, concentration of A raised power M, concentration of B raised power N. All right, let's move ahead. So now, the likely question that can be asked under the rate law expression is to be asked that what is the overall order of the reaction? So when you are given a rate law expression, you can be asked that what is the overall order of the reaction? What is the overall order of the reaction? Now take note of this. The overall order of the reaction is always an addition of whatsoever you find here and whatsoever you find here. That is the order of the reaction with respect to A and the order of the reaction with respect to B. So in this case now, the overall order of the reaction will be equal to M plus N. M plus N. Like I said, what is here plus what is here? Order of the reaction with respect to A plus order of the reaction with respect to B. Now, I said this the other time too, that it doesn't necessarily have to be M and N here. It could be X and Y. So if this place is X and this place is Y, and you are being asked, what is the overall order of the reaction? The overall order of the reaction becomes X plus Y. It becomes X plus Y. It is possible that what you will find here is P and Q. So if this place is P and this place is Q, the overall order of the reaction becomes P plus Q, and so on and so forth, depending on what you have there. Also, let's look at how the rate law expression can be asked in the form of a calculation question. For instance, let's look at a question of this nature. In a reaction, A plus B to give C plus D. In a reaction, A plus B to give C plus D. The following observations were made. The following observations were made. The following observations were made. 1. Doubling the concentration of A doubled the rate. 2. Doubling the concentration of B doubled the rate. So the question is, determine the rate law and the overall order of the reaction. Now look at a question of this nature. Yes, let's look at this question. So the question says, in a reaction, A plus B to give C plus D, the following observations were made. From our figure 1, doubling the concentration of A doubled the rate. That's from our figure 1. From our figure 2, doubling the concentration of B doubled the rate. So the question says, determine the rate law and the overall order of the reaction. So how do we go about solving this kind of question? So if you want to solve a question of this nature, a question of this sort, what you are to do first of all is to write or to propose a rate law expression for this reaction, to propose a rate law expression for this reaction. For instance, since the reaction was A plus B to give C plus D, so if we are to propose a rate law expression for this reaction now, the rate law expression becomes R is equal to K, concentration of A raised per M, concentration of B raised per N. Now you are seeing A and B here because in the reaction, what we have is A plus B. All right. So now, when you look at the question, two observations were made. And the first observation was that doubling the concentration of A doubled the rate. So let's try to represent that in the form of a word problem, for instance. So if the concentration of A is doubled, that is, if A is equal to 2A, then we were told that the rate was also doubled. That means R becomes 2R. Yes, this is a representation of the first observation. Because the first observation says that if the concentration of A is doubled, that is, if A becomes 2A, then the rate of the reaction is doubled. That means R becomes what? 2R. R becomes 2R. So, meaning that anywhere we see A now, we replace it with 2A. Anywhere we see R, we replace it with what? 2R in the rate law expression. So, in our rate law expression now, instead of writing R, we write 2R is equal to K. Then instead of writing A, we write 2A. All right? Raised power M. Then we write B raised power N. So let's simplify further. So that becomes 2R is equal to 2 raised power M K. Concentration of A raised power M. Concentration of B raised power N. Now if you notice, from here to here resembles our R. If you look at from this K to our N, you notice that it's the same thing as our R. So that means we can actually replace this expression with R. So that becomes 2R is equal to 2 raised power M R. R can cancel R. Now, we need to ensure that they have the same base so that they can cancel out. Now, remember that 2 is the same as 2 raised power 1. So 2 raised power 1 is equal to 2 raised power M. 2 cancels 2. M is equal to 1. So we have gotten our M, but we are not done because we still have to look for our N. So the second observation is what we will use to get our N. And the second observation says that doubling the concentration of B doubled the rate. So let's represent that in the form of a word problem again. That is, if the concentration of B is equal to what? 2B, then R will be equal to 2R. That is, the rate will also be doubled. The rate will also be doubled. So now that becomes, anywhere you see B, you represent it with 2B. Anywhere you see R, it represents it with 2R. So instead of R now, write 2R. 2R is equal to K, concentration of A raised power M, then 2B raised power N. 2B raised power N. So that becomes 2R is equal to 2 raised power N, K, concentration of A raised power M, concentration of B raised power N. All right. So now, again, you notice that this actually resembles our R. So that means that this is replaceable with R. So that becomes 2R is equal to 2 raised power N R. R cancels R. Let's ensure that they have the same base again. 2 is the same as 2 raised power 1. So 2 raised power 1 is equal to 2 raised power N. 2 cancels 2. N is equal to 1. So we have gotten our M and we have gotten our N. So the question said, first of all, we should determine the rate law. The rate law. So what will be the rate law for the reaction? The rate law for the reaction now becomes R is equal to K, concentration of A. What did we get as the value for our M? 1. So we don't have to put the 1. Then concentration of B. What did we get as N? 1 also. So we leave it like this. So this is our rate law now, the rate law expression. Then secondly, the question says, what is the overall order of the reaction? Overall order. Overall order. Like I told you earlier, the overall order is what is here plus what is here. So here we have 1, here we also have 1. So the overall order becomes 1 plus 1, which is equal to 2. So that is a second order reaction. A second order reaction. A second order reaction. A second order. All right. So our rate law becomes R is equal to K, concentration of A, concentration of B. But the overall order becomes 1 plus 1, which is equal to 2. Which is equal to 2. All right, let's look at another question. Another similar question of this sort. Okay, look at this question. In a reaction, A plus B to give C plus D, following observations. The following observations were made. Following observations were made. For figure 1, doubling the concentration of A quadrupled the rate. Doubling the concentration of A quadrupled the rate. From figure 2, doubling the concentration of B increased the rate by a factor of 8. So determine the rate law. Determine the rate law and the overall order of the reaction. Determine the rate law and the overall order of the reaction. So look at this question again. The question says, in a reaction, A plus B to give C plus D, the following observations were made. The first observation, doubling the concentration of A quadrupled the rate. The second observation, doubling the concentration of B increased the rate by a factor of 8. Determine the rate law and the overall order of the reaction. So we have to determine the rate law and the overall order of the reaction. So how do we go about this kind of question again? How do we go about this? Yes, we are still going to be following the same approach that we used in solving the first question, in solving the first one. So how do we go about that? So first of all, we solve this kind of questions by, first of all, writing out our rate law expression. By writing out our rate law expression. And what is our rate law expression again? Now, Recall that our rate law expression is R is equal to K, concentration of A raised power M, concentration of B raised power N. Now, so the first observation says doubling the concentration of A quadrupled the rate. What's the meaning of quadruple? Quadruple means that the rate was increased 4 times. The rate was increased 4 times. So let's represent that in the form of a word problem. So meaning that according to observation number 1, if the concentration of A is equal to 2A, then R is equal to 4R. That is, if the concentration of A is doubled, then the rate quadrupled. The rate quadrupled. So anywhere we see A, we represent it with 2A. Anywhere we see R, we represent it with 4R. So let's bring it to the rate law expression. So instead of R, we write 4R is equal to K. Instead of A, we write 2A raised power M, then B raised power N. All right. So having said that, we are going to have 4R is equal to 2 raised power M, K, concentration of A raised power M, concentration of B raised power N. Now looking at this whole expression represents our R. This is equal to R. So that becomes 4R is equal to 2 raised power M R. R cancels R. So how can we ensure that they have the same base? 4 is the same as 2 raised power 2. So 2 raised power 2 is equal to 2 raised power M. 2 cancels 2. M is equal to 2. M is equal to 2. But we still have to calculate our N. So according to observation number 2, says that if the concentration of B is doubled, that is, if the concentration of B is doubled, meaning that if B becomes 2B, then R is equal. The question said that the rate increased by a factor of 8. That means R becomes 8R. So in our rate law expression now, instead of B, we write 2B. Instead of R, we write 8R. So let's bring that to the rate law expression. So instead of R here, we write 8R is equal to K, concentration of A raised power M, then 2B raised power N. So what does that become? So that becomes 8R is equal to 2 raised power N, K, concentration of A raised power M, concentration of B raised power N. Now, this whole expression resembles our R. So what does that become? 8R is equal to 2 raised power N R. R cancels R. Again, let's ensure that they have the same base. 8 is the same as 2 raised power 3. So 2 raised power 3 is equal to 2 raised power N. 2 cancels 2. N is equal to what? 3. N is equal to 3. But the question said we should determine the rate law. The question said we should determine the rate law. So what would the rate law be? What would be the rate law? The question said determine the rate law. What would be the rate law? So the rate law R now becomes R is equal to K, concentration of A. What did we get as our M? We got our M to be equal to 2. Then concentration of B. Then we got our N to be equal to what? 3. So this will be the rate law expression. But not only that, the question also said we should determine the overall order of the reaction. So the overall order of the reaction will be an addition of this and this. So that becomes 2 plus 3. The overall order of the reaction here, okay, so we got the order of the reaction with respect to A to be equal to 2, just like you can see, that of B to be equal to 3. So the overall order of the reaction becomes what we have here plus what we have here. So that becomes 2 plus 3. And that is equal to 5. A fifth order reaction. So in the JAMB pass question, in 1997, for instance, if you look at 1997, question 27, for example, in your JAMB pass question. So there was a particular question. So there was a particular question that says, if the rate law, in the equation above, the rate of formation, if the rate law for a given reaction is R is equal to K, concentration of X raised per N, then concentration of Y raised per M. So this was the rate law given in the question. So the question says, what is the overall order of the reaction? So option A says NM. Option B says N over M. Then option C says N plus M. Then option D says N minus M. So from what we have on the board, so we were given this rate law, and the question is asking you that what is the overall order of the reaction? So like I've told you, anytime you are asked for the overall order of the reaction, it is always an addition of the order of the reaction with respect to this and the order of the reaction with respect to this. So the overall order of reaction becomes N plus M. And that is option C. Option C is correct. Option C is correct. Also in 1999, question 26. 1999, question 26. Question 26. So the question says, X plus Y to give Z. The rate equation for the chemical reaction above, is minus change in X all over change in T is equal to K, concentration of X raised per 2. Concentration of X raised per 2. Then concentration of Y. Concentration of Y. So the question is also asking us for the overall order of the reaction. Now look at this. Instead of writing rate or R here, they represented with this. So obviously from what we learned earlier concerning how to write rates expression for reactions, you notice that for the fact that there is a negative here, it simply means that X is a reactant. And of course, that's correct. Because if you look at the equation given to us in this question, the equation says X plus Y to give Z. So X is obviously a reactant. And that is why for this rate law expression, you notice that this is carrying a negative sign. Just to prove, to indicate that X is a reactant. So now, the question is asking us for the overall order of this reaction. What will be the overall order? The overall order is an addition of what is here and what is here. So here there is a 1 which you cannot see, obviously, but it is not always written because it is not necessary. So the overall order now becomes 2 plus 1, and that is what? 3. So that's the third order reaction. A third order reaction. So also there is another aspect of this that we need to talk about. There's another aspect that we need to talk about. Look at a typical question, for example. A typical question. All right, look at this question. For instance, in a reaction A plus B to give C, the following observations were made. Number figure 1, the rate of formation of C was found to be independent of the concentration of A. Number figure 2, the rate increased 2 times when the concentration of B was doubled. Determine the rate law and the overall order of the reaction. Now, this is the thing. The first thing I would like you to note here is that if this is our rate law expression, for instance, R is equal to K, concentration of A raised per M, concentration of B raised per N. Now, anytime you hear this particular statement number 1, that the rate of formation of C was found to be independent of the concentration of A. Anytime you hear this statement, what this statement simply means is that the order of the reaction with respect to A is 0. So what am I saying in essence? What I'm saying in essence is that anytime you are solving a question under the rate law and you are being told that the rate of formation of the product is independent of the concentration of one of the reactants, what that simply means is that the order of the reaction with respect to that reactant is equal to 0. It's equal to 0. That's the literal interpretation to that. So meaning that in this particular question now, that means, so since the question said the rate of formation of C was found to be independent of the concentration of A, what does that mean? It therefore means that don't bother calculating M because M is equal to 0. Because M is equal to 0. Meaning that the order of the reaction with respect to A is 0. Is 0. The order of the reaction with respect to A is 0. So, since we have been able to establish that, okay, let's write our rate law expression. R is equal to K, concentration of A raised per M, concentration of B raised per N. So now we have been able to establish that M is equal to 0. But the second observation says that if the concentration of B is doubled, then the rate is also doubled. So let's solve for that. Let's solve for that. So anywhere you see B now, you put 2B. Anywhere you see R, you put what? 2R. So what does that become? That becomes R is equal to K, concentration of A raised per M. Instead of B now, you write 2B raised power N. 2B raised per N. So what are you going to have? R is equal to 2 raised per N, K, concentration of A raised per M, then concentration of B raised per N. So from what you can see now, you notice that this is equivalent to our R. So what does that become? R is equal to 2 raised per N. All right, but our R here is 2R from what we have here. All right, so that's 2R. So your R can cancel your R. Now recall that 2 is the same as 2 raised power 1. So 2 raised power 1 is equal to 2 raised power N. then our 2 can cancel 2. So N is equal to 1. But then, the question said we should determine the rate law. So we are not expected to stop here. So what will be the rate law? The rate law now becomes R is equal to K, concentration of A. Now we already concluded that our M is 0. So what will be here will be 0. Then concentration of B raised per 1. Also, the question said we should find the overall order of the reaction. Overall order. So the overall order becomes 0 plus 1, and that is equal to 1. A first order reaction. First order.